Again, this video is going to be on electrolytic cells. It is page 7 of your notes packet, I believe. Page 7 of them. 1 second, a little closer. So we've been doing voltaic or galvanic cells, which are batteries. Okay, so those produce electricity. Galvanic, voltaic cells produce electricity, make a potential difference between two elements. One's giving electrons, one's taking. They produce electricity. These cells need electricity to run, so they need an outside source. They need a battery. So the other cells we've been doing were spontaneous. These are actually non-spontaneous. Okay, they're non-spontaneous things. So electric current is supplied by an outside source and forces a non-spontaneous reaction to occur. So something that would normally not occur. So the electrons are coming from an outside source and making something that's non-spontaneous to occur. So negative change. Remember, voltaic galvanic cell is a battery. Electrolytic cell needs a battery. Here's some uses for this. Electroplating, like jewelry. You don't buy pure gold. 14 karat, 16 karat, 18 karat gold is a piece of metal with a really thin layer of gold. It'd be too expensive to make pure gold, so it's always coated with that. Bumpers on cars, they put chromium around them. Galvanized washers, they put zinc around a piece of iron. Okay, so it's adhering one type of metal to another type of metal. It's also used for charging a battery. Okay, so let me show you a little bit about that.
Go into the silver, and now the.
All right. So we kind of do this in general chemistry, not done in here, but we make a penny gold, actually silver first, and then we make gold. But first we make it silver with some zinc. So we take the piece of copper penny and make some zinc stick to it. It's called electroplating. So here's kind of a general idea of what's happening. So you are using a battery. This one's connected to a piece of silver and a piece of copper. Okay, so the battery is supplying electrons. Now, electrons are going this direction in a battery. Okay, kind of the opposite of what you think, but they're going this direction in a battery. So electrons are going, they're connected to the piece of silver. Electrons are going out of the piece of silver into the piece of copper. Okay, they're going that direction. Well, as the silver loses electrons, this solid silver becomes silver ions. You're going to have some silver ions in there. When we electroplate a penny, I just put some zinc solution in there. So there's already zinc plus 2 ions floating around. So anyway, you can get some ions in there. So the main thing here, we have some ions floating around. Dissolved silver. We're trying to coat this piece of copper with some solid silver. So you got these silver ions floating around. What happens is these electrons come through here. And when they go through the piece of copper, copper does not want to gain electrons. They go into solution. These silver ions pick up the electrons and adhere to the copper. So the electron, here's kind of a microscopic view of electrons going in here. Electrons come in here. Electrons touch that piece of silver that's aqueous. It gains an electron and then becomes solid silver and adheres to the surface of the copper for some reason. So it's called electroplating. So you get this thin layer of silver on the outside of there as you do this. The more current you supply, the more electrons you supply, the more silver ions that can plate onto that piece of copper. And all of a sudden you have a piece of copper covered in silver. That's what we do with a penny. All right, let's go back now to your notes. Here's some information you got to know. So this is on your blue sheet, at least this part is. I is current. I is your current. Q is charge. T is time. I current. Q equals your coulombs of charge. And T is time in seconds. Okay. The unit of current is an amp or an ampere, and it's 1 coulomb per second. So 1 amp equals 1 coulomb of charge per second. So it's 1 coulomb of charge coming through something per second. 2 amps would be 2 coulombs of charge each second. 3 amps would be 3 coulombs of charge per second. So more electrons, more coulombs of charge. A volt is 1 joule per coulomb, amount of energy per coulomb. And a Faraday is that many coulombs per mole of electrons. So more moles of electrons, more coulombs of charge. 2 coulombs of electrons, 2 Faradays, that many more coulombs. So we're going to use these things. So use your labels greatly on these. Use your labels. Do a little bit of math on this. It's going to be pretty brief math. So this first one, what mass of copper? So we want to know grams of copper. We want to get to grams of copper. So that means we probably need to get to moles of copper and then get it into grams. Let's play it out when 10 amps is applied to some copper 2 sulfate solution for 30 minutes. Let's think about that. We have copper 2 sulfate would have copper ions floating around. You're putting amps of current in, putting electricity in. So that means this is gaining some electrons. It's going to, and every time that gains 2 electrons, you start getting some solid copper. And we're going to try to figure out how many grams. If we put 10 amps of current in there for 30 minutes, how many grams of copper would solidify out of there in that solution? Go from aqueous to solid. So remember, we can write this 10 amps as 10 coulombs of charge per second. So if we think about this, we can get minutes into seconds, we can go seconds to coulombs, and we can go coulombs to electrons from a Faraday to moles of electrons, and then we can get to moles of copper from there. All right? So we are going to start with 30 minutes. Use your labels. Make sure they cancel. I'm going to go 60 minutes. Sorry. I'm going to go 1 minute. And 60 seconds. Because I know that 10 amps is 10 coulombs per second. So you typically never write the word amps in these problems. You'll write coulombs per second. So we're going to say every 1 second, there's 10 coulombs of charge being applied because it's a 10 amp current. We are at coulombs, so you're looking for a way to get coulombs out of there. We know coulombs has to go on the bottom. You can use Faradays, which is coulombs per mole of electrons. So 96,485 coulombs per mole of electrons being transferred. So we are now at moles of electrons. Well, when we had that little copper in there, it's going from copper plus 2 to solid copper, which is a 0. So that means that there's 2 moles of electrons. 2 moles of electrons for every mole of copper that comes out of solution. And then we can go moles of copper, 2 grams of copper. And it's about 5.92 grams. So if you hooked up a battery to this solution that had some copper ions in it, ran electricity into that solution for 30 minutes at 10 amps of current, you only get 5.92 grams of copper out of there. If you would double your current, you'd double as much or go a longer time. All right. Number 2 here is asking how long, so we need to get to time. So we're probably going to get to seconds. I'll probably put my answer in minutes from there. This is 5 amps of current. Remember, that means 5 coulombs per second. As soon as you see that amps, means 5 coulombs in 1 second. To produce 10.5 grams of silver metal, okay? And it is silver nitrate. So silver nitrate is just AgNO3. That means your silver is just going from silver plus 1 to silver. All right, so it's just 1 electron per mole of silver being transferred, 1 electron per mole of silver. We want to finish with time. I know this gets me from coulombs to time. So I know that gives me, that is 5 coulombs in 1 second. So I don't want to start with that. So I'm going to start with my 10.5 grams. So I'm going to go 10.5 grams of silver, convert that to moles, which is 108 grams per mole of silver. I know that every mole of silver is a mole of electrons because it's just a plus 1 to a 0 charge. And then I can say that there are Faraday's constant. Every mole of electrons is 96,485 coulombs of charge. So that's just that Faraday's constant up there. And then I can use my amps to get from coulombs to seconds. There's 5 coulombs of charge every second. I'm going to go seconds to minutes. We maybe could go hours even. And you get about 31.3 minutes. It's a little tough to know here, but know that Faraday's constant gets you from moles to coulombs, amps, coulombs to seconds, or vice versa. So you can use those in any way you need to. All right. I will do maybe one more here. What do we got for a video? All right. Next one, figure out the quantity of electricity. Coulombs. We might put our answer into amps, actually. Okay, I think maybe we'll put it in how many amps of electricity would you need, how many coulombs per second. So we'll figure out how many total coulombs there are. I guess we need to know some time to get it into amps. But so we'll start here with our 100 grams of copper sulfate. No, 100 grams of copper, sorry. Remember, we're trying to get copper sulfate, which is a copper with a +2 charge, into solid copper, so +2 electrons here. So it's going to be 2 electrons to transfer here. Let's go grams to moles, which is what, 63.5 per mole of copper. I know that every mole of copper is 2 moles of electrons. And I want that because I know I can use Faraday's constant to get from moles of electrons to coulombs of charge. Every mole of electrons that's transferred, every time we transfer a mole of electrons here, it is that 96,485 coulombs of charge. 96,485 coulombs of charge. So if we do that, we get 303,890 coulombs. So we need that much electricity to get 100 grams of aqueous copper into solid copper. Now, if I want to know how much current that was, we need to know time. So let's say we did that for an hour. Let's say we did that. Let's say it took 1 hour to get all 100 grams of solid copper made. So remember, amps are coulombs per second. So if we divide that by the number of seconds in an hour, which is 3,600 seconds. So if we divide this by 3,600 seconds, it will tell us the number of coulombs needed per second. And that's about 84 coulombs per second, which is the same thing as 84 amps. You would need 84 amps of current running for an hour to get 100 grams of copper made in that solution. All right. Next couple, let's try and figure out. This one's asking for liters of chlorine gas. You got to get to moles. Remember, at STP, 22.4 liters is a mole. This one's asking for time, so you can kind of look back at those from there. See if we can answer those last 4 questions on there.